Okay, good morning everyone. Today we will solve some more problems on unsymmetrical fault. So take this problem. So a three-phase generator with an open circuit voltage of 400 volt is subjected to an LG fault. So single line to ground fault through a fault impedance of J2 ohm. Determine the fault current if Z1 is equal to J4 ohm, Z2 is equal to J2 ohm and Z0 is equal to J1 ohm, and repeat the problem for LL means line to line fault and LLG fault, that is double line to ground fault. Solution. First take this problem. So in this problem he has asked for line to line. So this first one is line to ground fault. So he has given through a fault impedance. Okay, fault impedance is also given. So that is second set of derivation. So we including with ZF. So we need to consider those circuit as well as those equations. Okay, so we need to write the sequence diagram for LG, that is single line to ground fault. So in that we need to write the network. So what is that network? We have positive sequence, negative sequence and zero sequence network. That is there, and neutral impedance is not given, so therefore leave it. Second one is negative sequence network. So reference bar, reference bus. In that reference bus, okay, and zero sequence impedance, that is called as Z0. This is Z0, this is Z2 and this is Z1, and this is called as EA1 is equal to EA, positive and negative. So through a fault impedance, that is called as ZF, through the fault impedance, that is ZF. So this is called as ZF. So now you substitute the values. What is the value of Z1? J4 ohm, 4 ohm. Value of Z2, J2 ohm, and value of Z0, J1 ohm, and fault impedance is J2 ohm. So this is 3 times of ZF. This is equal to J2 into 3. This is equal to J6 ohm. So in this first LG fault case, so what is IA1 and IA2 and IA0? All are equal because it is a series circuit. This is IA1, this is IA2 and this is IA0, right? Series, all the currents are equal, and therefore IA1 is equal to IA2 is equal to IA0. So that is equal to Kirchhoff voltage law apply here. EA divided by total impedances. Okay, total impedance is Z1, Z2, Z0 and ZF. That is 3 times of ZF. So that is equal to, so voltage divided by, that is EA divided by Z1 plus Z2 plus Z0 plus 3 times of ZF. So substitute the values. So here voltage, open circuit voltage is given, that is 400 volt. Line voltage is given, VL is equal to 400 volt. So this is EA this is the phase voltage. So therefore VPH is equal to VL by root 3, that is 400 by root 3. So therefore your current will becomes, so EA is equal to 400 divided by root 3 at an angle 0 divided by J is common in all the impedances, 4 plus 2 plus 1 plus 6 ohm, 6. So calculate it, how much it is. What is the value? Hello? How much you got? IA1 or IA0? So we will get minus J into 17.765 ampere in terms of rectangular coordinate system. So we need to find out fault current. Fault current IF is equal to magnitude of IA0. So therefore, what is that magnitude of I0? So take only magnitude. So this is equal to, that is 3 times of IA0. So therefore 3 times of 17.765. How much it is? IF is equal to 53.295 ampere. All of you got this?
Yes, sir.
So this is about single line to ground fault. Okay, while solving the problem, you must thorough with what is the circuit. If you draw the circuit, you can easily write the equation. Okay, so you can remember the equation according to the circuit. So then it will be easy for you. Okay, so it is difficult to remember all the equations. So right, so therefore you remember what is the circuit is there for LG fault, LL fault and LLG fault. From the circuit we can easily write the equations, right? So now we can move towards the second one, that is LL fault. So double line fault with fault impedance. Okay, these are comes under second set of derivations. So first set of derivation without impedance, second set of derivations So LG fault, LL fault, and LLG fault with impedance, with fault impedance ZF. So in that we are doing the problem. So right, for LL fault, so positive sequence and negative sequence are combined together. So we'll write the circuit, and zero sequence network will be drawn separately here. So therefore this is positive, this is negative. In between there is a fault impedance, that is ZF. In this case ZF is equal to, directly here no need to write 3 times of ZF, so that will comes under in only LG fault. So in this case this is EA1 is equal to EA, this is Z1, and current flowing is IA1 is in this direction, and current flowing IA2 in opposite direction, and this is Z2, and voltage across these two are similar, that is VA1 is equal to VA2 in this case. This is diagram A, and zero sequence network diagram is separately drawn. So this is called as IA naught and VA naught. VA naught will become 0 because it is a short circuit, and this is called as Z naught. Z naught is given, that is equal to 1 ohm, J1 ohm, and Z1 value is J4 ohm, and Z2 value is J2 ohm, and ZF value is also J2 ohm. Okay, so in this case IA1 and IA2 can be calculated by, what is IA1? EA is there. This is a complete series circuit. Okay, so there are three impedances are in series, Z1, ZF, and Z2. So therefore EA divided by Z1 plus Z2 plus ZF, that will give Z2 plus ZF. In previous case we have added here 3 times of ZF, so that is the difference here to find out the IA1. And also in previous case IA1, IA2 and IA0 are equal, but in this case not equal. Therefore EA is equal to 400 by root 3 divided by Z1 value is take J common, 4 plus 2 plus 2. So what an angle 0 here. So calculate the value of IA1. What is the value? Hema, what is the value? Hello? Kirti, what is the
Yes,
value
sir.
of IA1?
Minus J 28.86.
J 28.86 or 87 ampere. Okay. So to find out the fault current, so in this case IF is equal to root 3 times of IA1. Okay. root 3 times of, so magnitude of IA1, that is 28.87. So here fault current is same. So but we need to write in terms of line current, root 3 times of that is IA1. So what is that IF value? We will get 50 ampere, right? All of you got the answer?
Yes, sir.
So similarly, you can write LLG fault. Third one. So while writing for LLG fault, so your diagram will be the reference. Is plus minus EA1 is equal to EA, and this is Z1, and this is the parallel circuit completely, because VA1 is equal to VA2 is equal to VA0 here. Z2 and this is Z0, and double line to ground fault means the fault impedance will be between Z2 and Z0. This is called as ZF. Here also you can take it as 3 times of ZF, that is equal to 6 ohm, J6 ohm, and VA0 here, VA2 is here, and this is VA1 here to here, and Z1 is J4 ohm, Z2 is J2 ohm, and Z0 is J1 ohm. So current flowing, this is called as IA1, and here the current flowing is IA2, and here the current flowing is IA0, in this direction IA0. So now we need to calculate IA1 is equal to, so first loop, so that is our IA1, that can be calculated by EA divided by, so current division rule we will take, so that is Z1 is in series with parallel combination of Z2, Z0 and 3 ZF. Okay, so 3 ZF and Z0, these two are in series. Therefore, 3 ZF plus Z0, this combination is parallel with Z2. Okay, so I will write here Z1 is series and it is parallel with series combination, and Z2 is parallel with 3 ZF plus Z0. So this is your circuit, right? So Z1, it is in series with parallel combination of these two. Okay, like this. This is Z1 is like this, here Z2 is there, here 3ZF is there, and here Z0 is there. So this is your circuit. So Z1 plus Z2 parallel with 3ZF plus Z0. So like this circuit is there. Okay. So therefore we can write it as EA divided by Z1 plus, so parallel combination Z2 into 3ZF plus Z0, 2 into Z0 plus 3 times of ZF divided by Z2 plus total combination Z0 plus 3 times of ZF. Okay. So substitute the values now. So EA is equal to 400 by root 3 at an angle 0 divided by, so J is common in all the cases. So take J common. So Z1 is 4 ohm plus Z2 is 2 ohm and Z0 is 1 plus 3 times of ZF, that is equal to 6 divided by 2 plus 1 plus 6 will give Ia1. So calculate it. How much it is? What is the value? What is the value of Ia1?
minus 41.569 J, sir.
A 41.57.
569. Sir.
57. Okay. So therefore, using current division rule equation, so we can write Ia naught is equal to, we need to calculate Ia naught now here. This is equal to, because it is in opposite direction, so main current is Ia1, main current. So these are all branch currents. Okay, Ia1 is main current, Ia2 and Ia naught are the branch current. So to find out branch current Ia naught, so main current is coming in opposite direction to the Ia naught. So minus of Ia1 into, what is the opposite resistance for Z0? Opposite resistance for Z0 is Z2. Opposite, that is impedance, divided by sum of total impedance in this circuit. What is the sum of total impedance? Z2, Z0 and ZF. So therefore Z2 plus Z0 plus 3ZF. So this is the current division rule. You got this? How to write the, how to calculate Ia naught equation? Current division rule. Main current into opposite impedance by sum of total impedance. So we need to consider this circuit here. So in this circuit, we are calculating the branch current. Okay, so branch current IA naught. So this IA naught is equal to main current, that is both are in opposite direction, is taken as negative. Main current into opposite impedance for Z naught is Z2 divided by sum of impedance in this circuit is Z2 plus 3ZF plus Z naught. Is it clear? So substitute that values and calculate it. So you know the value for IA1. So IA naught is equal to, what is IA1? J41.57. Z2 value is 2 divided by 2 plus 1 plus 6. So calculate IA naught. Two plus 1 3, 3 plus 6 9, 2 by 9 into 41.57 J. We will get J 9.24 ampere. So fault current IF. So what is the fault current flowing in the impedance here? So fault current is flowing here in terms of IA naught. That is 3 times of IA naught. So fault current IF is equal to 3 times of magnitude of IA naught. So this is equal to 3 into 9.24. Fault current is equal to 27.72 amp. Is it clear?
Yes, sir.
So in this problem, so he has asked for 3 cases. First case for LG fault, second case for LL fault, and third case for LLG fault. In all the cases, we need to calculate the fault current. Okay, so that is called as IF. In all the cases, we have calculated the fault current. In first case fault current is we got 53.29. In second case we got 50 ampere. In third case we got IF is 27.72 ampere. Okay, for the different types of fault. Can I clear the board? Okay, take next problem. A three-phase generator a three-phase generator with line to line voltage of 400 volt is subjected to an LLG fault if Z1 is equal to J2 ohm, Z2 is equal to J.5 ohm, and Z0 is equal to J.25 ohm. Determine the fault current and terminal voltages. This is the problem. Three-phase generator with line-to-line voltage, that is line voltage is given 400 volt, subjected to the LLG fault. In this case, with fault impedance is not given, ZF is not given, right? So this is comes under the first set of equations in that third derivation. First set of derivation in the LLG third derivation. This is related to that one. So we need to write the sequence network for this without fault impedance. Okay. So solution. So draw the circuit for LLG fault. So for LLG fault, there is a parallel circuit because VA0, VA1 and VA2 are equal. So therefore, can write positive sequence network and negative sequence network and zero sequence network, all are in parallel. So this is equal to EA1 is equal to EA. This is Z1 is equal to J times of 2 ohm. Z2 is equal to 0.5 ohm. This is Z2 0.5 ohm, J 0.5 ohm, and Z0 is equal to J 0.25 ohm. And current IA1 is flowing like this, IA2 in this direction, and IA0 is also in opposite direction. And what about the VA? This is VA1 here to here, and VA2 and VA0. So what is the EA here? EA is equal to 400 by root 3, because the line voltage is given 400 volt. We want EA. EA means that is the phase voltage, EAN with respect to the neutral. So that is equal to phase voltage is equal to, in case of star connection, 400 divided by root 3. So we got 230.94 at an angle 0 degree. So calculate IA1 is equal to, so look here, IA1. So what is the current IA1 here? IA1 is equal to, so EA divided by J into, so this is Z1, that is in series with parallel combination of other two impedances, that is Z2 into Z0 by Z2 plus Z0. So therefore EA is equal to 230.94 at an angle 0 degree. J times of what is Z1, that is 2 ohm. Z2 is equal to 0.5 and Z0 is equal to 0.25 divided by 0.5 plus 0.25. So calculate it, how much you got IA1 value. So do it fast. What is the value of IA1? Maruti, what is the value of IA1? Rajahatti,
minus 106.59 J answer.
minus J 106.59
106.59.
or 59. So similarly calculate IA2. So what is IA2 here? So using the current division rule, we'll write IA2 is equal to main current IA1, but it is in opposite direction. So minus IA1 into for Z2 and Z0. So which one is the opposite impedance? Z0 is the opposite impedance divided by sum of the total impedance Z0 plus Z2. This is the branch division rule. So is it clear how to take the branch division rule? Anybody having the confusion in current division rule? You have already studied in the network analysis, right? According to that, you need to take. So this is minus IA1 is equal to J106.58. So minus of minus get plus, and Z0 is J0.5 divided by J0.25 plus J0.5. So calculate it, you will get IA2. So you will get J 71.05 ampere. That is IA2. So what is IA naught? Anybody give the equations for IA naught? Rajini, what is IA naught?
Yes, sir.
IA naught is equal to not audible. Your voice is not audible.
Minus IA1 into Z.
Not audible.
Minus I
Minus. What is the
into Z2 divided by Z0 plus Z2.
minus IA1, right? That is the main current is IA1. We are calculating the branch current. So therefore minus IA1 into opposite impedance for IA naught. So this, what is the opposite impedance for Z naught? Z2 is opposite impedance by sum of total impedance Z2, Z0 plus Z2. So minus IA1. So minus of minus plus J 106.58 into J.2 Z2 J.5. Sorry, here this is 0.25. Mistake is there. 0.25 by 0.25 plus 0.5 here. J.5 divided by J.25 plus J.5. Okay. So IA naught will become, so this one is value is
71 point.
0.53 ampere. So this is J
71
ampere. Okay, IA2 is you got 35.53, not 71.25, right? 71.05. So there is a mistake happened here. Okay, so once you got the IA naught, we can easily calculate the fault current IF is equal to 3 times of magnitude of IA naught. 3 times of magnitude is 71.05. So what is that value? 213.15. That is your fault current. Okay. So in the problem we have calculated the fault current, right? So what is the remaining is there? Determine the fault current and terminal voltages. So we need to calculate the terminal voltages now. What are the terminal voltages? VA1, VA2 and VA0. We need to calculate. Terminal voltages means that is the line voltages. Terminal voltages means line voltages, that is VA, VB, VC. We need to calculate VA, VB and DC. To find out VA, VB, VC, we require VA1, VA2 and VA3. So VA0. Therefore, capital VA1 is equal to, so J into root 3. So we have done this one in phase sequence, the shifting of phase sequence derivation. J root 3 into small VA1 okay, and VA2 is equal to minus J root 3 into small VA2, and capital VA0 will become 0. The line component of 0 sequence voltage is always absent. So these are phase voltages. So these are small values, that is equal to 0. So we require small VA1, small VA2, okay, or small VA0. So how to find out small VA1, small VA2 and small VA0 here? So in this case all are equal, VA1, VA2 and VA0, because parallel circuit all the voltages are equal. So that will be given by EA minus IA into Z1. So EA is 230.94 minus at an angle 0 degree minus what is IA value minus J not 6.58 into Z1 is J2 ohm. So what is that VA1? We will get 17.76 volt. So once VA1 and VA2 all are equal, so substitute here. So capital VA1 is equal to 17.76 into J root 3. You will get 30.76 at an angle 90 degree. And second one minus J root 3 into VA2. VA2 is also equal to VA1. 17.76 into minus J into root 3. That is 30.76 at an angle minus 90 degree. So J means 90, minus J means minus 90, plus J means plus 90. And VA naught is 0 because line component of 0 sequence current. Hence voltage is always absent. So now we need to calculate capital VA, capital VB and capital VC. So capital VA is equal to VA naught plus VA1 plus VA2. VA naught that is 0. VA1 calculated J 30.76 plus VA2 is minus J 30.76. Right? Minus 90 means minus J we can write. Plus 90 angle is write it as plus J. Okay. So this get cancelled. VA will become 0. And similarly calculate VB is equal to capital VA naught plus A square into VA1 plus A into VA2. VA naught is 0. A square that is 30 point VA1 is 30.76. So J is 90 plus A square means 240. Write it as 240 plus VA2 is equal to 30.76 at an angle minus 90 plus A means 120. 120 degree. A square is 240 degree. A is 120 degree. Calculated. So VB you will get 53.26 volts. Similarly, you calculate VC. VA naught plus A into VA1 plus A square into VA2. VA naught is 0. So 30.76 at an angle 90 plus 120 plus 30.76 at an angle minus 90 plus 240. How much it is? Almost we will get same value 53.26 volt. So in this case VB VC must be equal. but this is opposite, minus 53.26 we got. All of you got this answer? Ismaya, you got the answer?
Yes, sir.
Any doubt regarding the problem?
No, sir.
So far, okay, so we will close the today's class. Okay, we'll discuss some more problems on tomorrow. So thank you very much.